Good day, ladies and gentlemen of Algebra 2 Extended. Mr. Kruger coming at you today. Lesson 1.4, Graphing Linear Equations. This, I'm assuming, is going to be a pretty short video. We're going to graph a few lines, and we're going to write the equations of a couple lines as we go through this quick lesson. Your task for today is, once you are done watching this video, we want you to complete the 1.4, try on your own assignment. And remember, that does not need to be sent in today. Once you're done, that just needs to be sent in by next Monday with your other assignments. So when we go here, graph the following lines. Okay. When I'm graphing my following lines, what I want to do is, they're just giving me two pieces of information here. They are giving me my x-intercept, so I'll plot my x-intercept at 4, 1, 2, 3, 4. And I have a y-intercept of 5. And remember, it only takes 2 points to make a line. So all I'm going to do is I'm going to connect these lines with arrows on both sides. And 2 points to make a line. And if they just give me the intercepts, all I have to do is plot those intercepts. It's very nice. And I will do my best to connect these lines. Whoa, didn't work for me. Hold on. Crumb. Grab my eraser. I didn't pick my line. That's my problem. I want to go here. I want to go there. I want to go to my lines. Then I want to make sure I got arrows on both sides of my lines. I'm going to have a semi-thick line. And I'm going to draw my line. And it should go through both points. And from there, I can extend that line. Notice how nicely that line goes through both of them. Okay? So that's all we need to do. If we're having the intercepts, it's all we have to do is plot the two, the x-intercept, the y-intercept, and graph the line. This next one, number 2, okay, if I wanted to do that, remember, if I plug 0 in for x, that gives me my y-intercept. So if I put in 0 for x, I really have 5y equals 20, right? So then y would equal 4. And if whoa, why did I put a 0 in there? I even set a 4. Let me come back. And I got a 4. And then if I put a 0 in for the y value, that will give me my x-intercept. So then if I did that, I really am looking at solving 2x equals 20. So I divide by 2, x equals 10. Okay? If I had a big enough graph, I could graph that. Notice my scale on this one, they're already labeled for me and they're only going out to 6. Well, I can't plot that. I don't want to extend the graph. So graphing by intercepts in this one probably is not our best avenue to go. So I'm going to go back. It would be if I had a big enough graph. So I'm going to come back and we're going to take this guy over and we're going to subtract 2x from both sides. We're going to put this in our favorite form, slope-intercept form. So we have 5y equals negative 2x plus 20. And then when I divide by 5, remember, I divide everything by 5. So these 5 cancels out. I get y equals negative 2 over 5 times x plus 20 divided by 5 is 4. And I can look right at this little rascal, picturing y equals mx plus b. When I'm solved for y, like I'm solved for y here, I can look at the equation and I can say my slope is negative 2 over 5. And I can say my b value, b, is 4. Well, my b value is always my y-intercept. So I'm going to plot my y-intercept from slope-intercept form. And then if my slope is negative 2 over 5, well, heck, I go down 1, 2 over 5, 1, 2, 3, 4, 5, and I make a point. It takes 2 points to make a line, but 3 points to make sure it's perfect. When you have a negative slope like that, you can put the negative with the 2 or the 5, like last time. If I flip this over and I call the slope positive 2, 1, 2 over negative 5, 1, 2, 3, 4, 5, I just go back the other way. I have 3 points. They look like they follow in a beautiful line there. I'm going to make it blue this time though. And I think I still got all that good stuff. So I'm going to come from there back through and check out that line. That is a, whoa, don't want to do that. That's a pretty sweet line. So it goes through both points. Okay, a couple more examples here. Let's go to the next one. Graph the following lines. Well, if I look at this one, I could use intercepts on this if I wanted to, but if you look ahead, if you put 0 in for y, I'm just going to write this up here quick. If I put 0 in for y, that's gone, but then I'm going to get x equals 6 over 4, and that's not a whole number. We don't want to plot fractions if we don't have to unless it's slope. We always want our points to follow right on a grid value, so we're not going to do it that way again. What we're going to do is we're going to subtract 4x from both sides, and we're going to have 3y equals negative 4x plus 6. We're hence going to divide by 3. We're after that really nice slope-intercept form again. We get negative 4 over 3 times x plus 6 divided by 3 is 2. So I can see m is negative 4 over 3. I can see my b or my y-intercept is 2. If I come right back, I put my 2. And then I'm going to say negative 4/3. I'm going to go down 4 for negative 4. 1, 2, 3, 4. Then I'm going to go positive 3, make my point. I can go down another negative 4 over 3, and I can make another point. Remember, I could tag that negative with the denominator, and I could go up 4 to the left 3. And no matter how many I make, look at that wonderful line that it throws out there. And then I will grab that line and I will connect. Whoa, I'm off just a skosh. For those of you that don't know my lingo yet, a skosh is called a little bit. And I can drag him back on. I'm not back on. Now I'm on. And that's a pretty sweet line. It goes through all 4 points I made. Number 4, oh, look at that little dog. That's a nice one to graph. They gave it to me right away. I'm already in slope-intercept form because my y is solved. So I'm like, hey, m is a 4th, b is 5. I really have no work to do on this one. I just got to go up and plot my 5. Then I go positive 1, right 4. That's 2 points, remember. We want, unless you're plotting by graphing by intercepts, we want more than 1 point. So I can say if I go a negative 1 and a negative 4, that's still a positive, and they still line up beautifully. And I can grab my line, and I can drop that rascal right through there, and I can extend him all the way through. Notice my line is going all the way through the graph. I'm not making baby lines. What do you mean by a baby line, Kruger? Well, here's what I mean by a baby line, just a little guy like that. Go all the way through your graph. We don't want to monkey around with baby lines. Okay, we're going to come, we're going to change page. Now, these next 2 examples really freak out students all the time, but I'm going to back up here a second. Every example we did before, let me point out one thing to you. Notice my equation. Notice my equation has an x in it and a y in it. Every equation prior had an x and a y, x-intercept and a y-intercept. Down here, I had an x, I had a y. Check it out. Notice I hit the y-axis on that one. If this line continues to extend down here, sooner or later, it will cross the x-axis over here. Okay? Next one. This has got an x and a y in it. Check it out. It hit the y-axis. It hit the x-axis. It hit both axes. This bottom one has an x and a y. you guessed it, there's the y-axis. If we extend this side, you can see it's going down. Sooner or later, way out there, it's crossing the x-axis. Okay? Check this one out. This one only has an x in it. You know what that means, don't you? Only an x. It will only touch the x-axis because there's only an x in it. Guess where it's going to hit the x-axis? You guessed it, -5. What's the only way I can draw a line through that point and never touch the y-axis? You guessed it, I have to be parallel to the y-axis, which means that is a perfectly vertical line. That is how you graph these in a single variable, if I can call it that. Example number, I forget, number 5. This must be number 6. I cut my 6 off of that one. But check it out. This only has a y in it. It will only touch the y-axis because it only has a y in it. Where is it going to hit the y-axis? You guys are good. Right there at 3. Because it will only hit the y-axis, that means I need to draw a line that will be parallel to the x-axis because it will never touch it. So it's a horizontal line. Y equals a number is a horizontal line. X equals a number is a vertical line. Very, very important little topic there, okay? The last 3 examples we have here is we want to write the slope-intercept form of each line. Well, whenever you're writing the equation of a line, think simple, think y equals mx plus b. If we have the slope, we have the y-intercept, we got it. Well, I can see right here, I can see b equals 3. And now the next thing I'm going to do is I'm going to follow that point either up or down, doesn't matter, but I want to find another point that it is hitting a grid mark, if I can call it that. So then I can count my rise of 2 over my run of 3 to say m is 2 over 3. My slope is 2/3. Then all I got to do is I got to come back and I got to say y equals 2/3 x plus 3. Somebody out there would be asking a question, hey, Mr. Kruger, what if it doesn't go through an actual grid mark on the y-axis? Can I make an assumption that it's going through 2.5? And I'm going to say no. If it's not going through an actual grid point, like right here, don't make the assumption that that is going through a half or a third, okay? We would need a different technique, which we would do later on this year anyways, okay? But when I'm looking, I can check this out. I'm like, whoa, there it is. It's going right through there. B equals -4. And then I need to slide up that line until I hit another grid mark. Well, that doesn't happen until way up here. Well, that gives me my slope. Remember, my slope is how far do I go straight up and then come straight across from point to point. Well, that's 2, 4, that's rise 6, run 5. And I went up and to the right. So those are both positive numbers. So I'm 6 over 5. So y equals 6 over 5, x minus 4 would be the equation of that line. Okay. Also, check it out. This blue line that's on there, it goes up and to the right. That means positive slope. Positive slope. Same one over here. It goes up and to the right. Positive slope. Last example we got here. Up and to the right. My slope is going to be positive. If your line goes this way, okay, you have to have a negative slope. Ours doesn't. Ours is going up, so we're going to have a positive slope. All we're going to do is we're going to look. Yup. It's given it to me. The b value is -2. and then I'm going to slide up that line. Looks like it hits right about here. So I go up and over. What are my units? Up 1 over 3. That means the slope is rise over run, or a third. Y equals 1/3 x minus 2. Whatever b is, if it's negative, it gets a minus sign. If it's a positive 2, it gets a plus sign. Okay? Whatever is here goes here. That sums us up here. You can go ahead and do your 1.4 assignment and have a great day.